welcome to this talk where I'm going to talk about testing with component harnesses for the win. So my name is Alain, or just Al, and I'm a Google developer expert in web technologies, more specifically Angular and Google Maps. And I've been working as a full-stack developer since 2006 and became addicted to AngularJS in 2011. And I've been pretty much working on front-end development on a daily basis since then. And these days I'm doing training and consulting at my own company, which is angulartraining.com. And I'm also the co-organizer of the Google Developer Group in Sacramento, California. So before we get into talking about component harnesses, I want to do kind of a reminder of what is the big picture of testing on the web these days, because we have many different ways to test things. We have many different technologies. So I kind of want to do a recap and give you a big picture of where things stand. And then we're going to get into this idea of component harnesses. So end-to-end integration, performance, or unit testing. These are some of the different kinds of tests that we have available these days on the web. And the one that people are usually most familiar with are unit tests, because unit tests are really the ones that are the closest to the developer. Really, the person who writes the code is the one who's supposed to write unit tests. So when you write a unit test, the idea is that you are going to validate a single piece of code in your application. Usually just one function or a few lines of code that you are going to test all of the inputs and outputs of that specific piece of code. So I have a tiny example here for a calculator app. We have a function add, takes 2 parameters, and the test is going to test that function passing a bunch of different parameters, making sure that the output is what is expected. So that's a unit test, and that's something I'm guessing most people are already familiar with. Now, something on top of unit tests usually, so one step higher, I would say, is what we call integration tests, where the idea there is not just to focus on one single piece of code, but instead we want to test the integration of several different pieces of code and make sure that they all work together the way we expect them to work. So it's really focusing on integration, focusing on interactions, and as a result, the test itself is a little bit closer to what an actual user would be doing with the application. So tiny example here as well. We want to make sure that we have a keyboard listener in place. So we are expecting that to be set up and that we have a function listening to events. And then we test entering keys by calling a function and making sure that it works properly. So it's really not a unit test anymore because we're validating event listeners and calling a function that is under the hood calling many other different functions and many different units of code. So that's really testing the integration of all of these pieces. These tests are more rare because usually people tend to either focus on unit tests and be very close to the code itself, or they would go with what we call acceptance or end-to-end tests, which is really now completely from the user perspective. How do we use the application? What is the application supposed to behave like? And when we do end-to-end tests, the test itself is really going to simulate user interaction. So it's all going to be about what happens when I click here, and then I type this, and then I click on this other piece, and check the result. That's really the idea behind an end-to-end test. These tests are also used to validate multiple environments. So that's what you would do. Let's say you have a web app, you want to validate that it works in Chrome, Edge, Firefox, many different browsers, for instance. That's a typical use case of end-to-end tests as well. So in my example test down here, I'm opening a web application in the Chrome browser. I'm clicking on 1 plus 2 and then equals, and then I'm expecting the result. So for this one, I do a screenshot comparison, which is something available with some end-to-end testing libraries. making sure that the end result looks pixel perfect, really what we expect in the first place. So that's end-to-end testing. Interacting with the user interface just like a real user and checking that it looks like what we expect in the end. And the final type of test that we have is known as performance test. So with performance tests, you want to validate the speed and the responsiveness of an application. So making sure that if you have lots of users getting on the app and doing lots of things, that it's still going to be pretty fast and remains usable no matter the workload. So usually when you do performance testing, you're going to focus on measuring how much time it takes to perform a specific operation and make sure that that time remains consistently low. So in the example down here, you can see that I'm expecting the load time of the application to be less than 10 milliseconds in that example. So these are really all of the different kinds of tests that we have available. And the reason why I'm talking about this as an introduction is because some of these tests are low level. That's unit tests, right? We focus on you have to know the code in order to write the unit test. You have to be aware of how things are written. It's really a task for developers. Then we have integration tests that are a little bit higher level, validate the behavior of combined units of code. Still, it would be a developer doing that kind of work. Acceptance functional tests, end-to-end testing, these ones are really higher level, a lot higher level, in a sense that you don't have to know how it's coded. You just have to know what the user interactions are and what are the expected results of these user interactions. So it's a much higher level. And performance testing, well, this one is, could be kind of in between integration and acceptance. It's on a similar level really as acceptance or end-to-end testing, I'd say. The idea is the higher level you get, the less visibility you have on the actual code behind the scenes. So why does this matter? Why talking about this? Because the thing is, as frameworks and web technologies evolve, the boundaries between these different types of tests have become more and more blurry. They really tend to disappear a little bit. And if you're using a modern JavaScript framework like React or Angular or Vue, you know that you can basically query the DOM and access elements in it and check what the UI looks like, which is really more than what a unit test should be supposed to do. Unit test should be just focused on individual functions, really. But now we have access to so many cool technologies that we can do a lot more with unit tests. So what should we do? What should we test? How, when, and where? That's kind of the idea of what I want to cover in this talk with component harnesses. And before I get into that, there's one last thing I want to talk about. That's the notion of the page object model pattern, which is something that you might be familiar with. The idea behind a page object model is that you have a class or a function that provides a higher level API to interact with an application, in that case with a web page. So that page object model would give you methods, functions that have explicit names that just make sense, that are easy to understand, easy to read, self-explanatory, such as login, enter address, add to cart, sign out, all of these different features that would be user actions on the web application. So a page object model is something that we usually have when we do end-to-end testing. It is a very common pattern in end-to-end testing, where for each page that you have in your web app, you would have this model that describes what are the different possible interactions on the page, what are the different things that a user can do. Those gets translated into functions, and that way writing tests around that page object model is a lot easier. So let's take an example to illustrate how this would work. So here we have a drop-down to select a currency. So when you click on it, it's going to open menu items, options, which are different currencies. and we want to select one of those. So with end-to-end testing frameworks, you would usually have something that looks like this. The syntax here is based on Webdriver, Selenium. So element by CSS, app currency switcher button. So this selects a specific component on the web page and clicks on it. So simulating a user interaction on that button. And once this is done, we select all of the options available with a subquery to select by partial link text to find the USD option, and then we click on it. So this is readable, kind of, but the thing is you have to be aware of the DOM structure, right? You have to know that this specific element on the page is a app currency switcher component and that it has a button on it. And then you have to know that all of these different options are actual HTML options. So you have to know the structure of the DOM. The code is a little bit verbose. As you can tell, it barely fits on my screen. And that would be the way we would write a regular end-to-end test without having that page object model. Now, if we have a page object model, these instructions, these commands really to interact with the UI, they are going to be translated into meaningful, easy to understand functions. So that's what I have at the bottom of the screen here, where doing the exact same task would be my page.select currency USD. And at that point, we have abstracted really the DOM. We don't have to know how it's written, what are the selectors, what is the structure of the DOM. We just want to test the user interaction. So we call a select currency function. We don't know how it gets done. That's kind of hidden from the test writer at that point. So these page object models, they are pretty widely used in end-to-end testing. They really make it easier to reuse code, to provide an API that is going to allow you to write test after test after test and maintain readability, reusing these common instructions and selectors instead of copy-pasting them around, having them in just one place, and then using this high-level API to write the test itself. So yeah, if you've ever been using Selenium, Webdriver, Protractor, you probably either used those page object models or found some documentation info about them on the web. Even the latest technologies in terms of end-to-end testing, such as Cypress, for instance, has a similar concept with commands. So they are not strict page object models per se, but the notion of command allows you to refactor a bunch of instructions and selectors into one single command. So this is an example for a login page. So we create a command called login, and we select the input for the username. We type the username into it. Then we click on the next button, select the password, type the password, click next. So that's the flow in order to log in that specific application. And by refactoring this code into a specific command, then I can use it as cy.login, passing an email and a password as a parameter, which is a lot more readable, a lot easier to understand, and even better if a few months down the line the login process changes because the user interface becomes different or the selector has to change in any of these instructions. You only have to update your code in one place, and that's this command. And the usage of that command remains the same. So that's something pretty powerful because it's a big time saver, and it makes every single test easier to write, easier to read, easier to maintain. So now we can talk about component harnesses. And the good thing about a component harness is that it is basically that same idea of page object, but applied at the component level. So a component harness is going to be an object that has methods, functions that can do operations on the component just like a regular user would. So instead of using the DOM and queries and everything, you're going to have access to a higher level API with explicit function names that are easy to to understand. And yeah, a component harness is just like a page object model, but at the component level instead of at the page level. So how does that work? How does that idea of component harness work? Well, the first thing you have to do if you want to do a test that's using a component harness is that you would select a component. So here we have a harness loader. We are going to call a getHarness method, which is really going to say, hey, query the DOM for me and find that mat dialog harness, which is a specific component that we want to interact with. So that's going to return that component known as popup here. And we can also apply that same idea to select several components, not just one. So here, popup.getAllHarnesses with a component type of mat button harness. So this would select all of the buttons inside that popup component. And once we have done that, we can interact with these components. So I can click on a button, I can get the text of a button, check what the text of the button is, and basically run my unit test just like I would do, just like we are used to already with React, Angular, Vue, or any other framework or JavaScript. So why do we need component harnesses? Why do these make a lot of sense? So I'm going to give you a bunch of reasons for that. Reason number one is that once you have a clear, well-defined API, possibly even typed using TypeScript, for instance, you get a lot of assistance from your IDE. So you get Intellisense or autocomplete when you are using that harness. So here I have an example with my button, and you can see that the IDE is suggesting all of the different methods that we have on that element. So that makes discovering the code a lot easier, interacting with it a lot easier. I don't have to go inside that component to see how it's written. Intellisense is going to do the job for me and is going to suggest all of the different options available. So that's a big, big plus. That, of course, you cannot get with just HTML elements that you would select with a CSS selector. Reason number two is that once you have these harnesses, your tests are easier to write, easier to read, easier to maintain. You remove a lot of the boilerplate, a lot of the selectors that are really difficult to read, and that increase the complexity of the test, and things become just, yeah, the flow of the test is just making perfect sense. So an example of test here, next question button is disabled after being clicked. So I select my button component harness, loader.getHarness mat button harness. I click on the button. I get the text, make sure that the text of that button is next question. And then I'm checking that the button is indeed disabled at this point. So 4 lines of code and a test that can be read easily. And yeah, that would be super easy to maintain. Reason number 3, when we use a harness API, our test is insulated from updates to the internal of a component. So if the DOM structure changes, or the CSS classes change, or we change the name of specific elements, or any change that we make to the DOM, basically, our tests are immune from that in the sense that all we would have to update is the harness API. We just update that in one place instead of all of the different use cases of that specific component. So without a harness, you have things such as document, query selector all, and then a complex selector, whereas with a harness, we just select the harness, get all of the options out of it. So we don't know what the DOM looks like behind it, we just know that we have a dropdown, that dropdown has options. How it is made, how are the options, what's the DOM behind it doesn't really matter. We just want to click the drop down, select an option, and we don't want to have to worry about these CSS classes. And reason number 4, which is really one of the most interesting ones when you think about it, because we talked about all of these different types of tests that we have available, from end-to-end to unit test. And the nice thing with a component harness is that it could be used in all of these different contexts, right? Because the way you interact with a component is the way that an actual user would interact with it, which means that this syntax applies to end-to-end, of course, but it can also apply to unit tests. And with one single harness API, you could, in theory, you could reuse that harness for all of your different types of tests and even have similar test scenarios end-to-end in the browser or unit tested at a very local level within a component. So this is great because it allows you to write tests that are going to work across frameworks and technologies possibly, because under the hood, our harness, well, is going to be just all about selecting DOM elements, right? That's all it does. It's going to query the DOM, return those elements, and maybe have some interactions with them. So if I want to implement a harness, let's say we have an example here for Cypress. It's a login method. So we select an element by a specific CSS selector. We type a username, same thing for the password, and then we click a login button. Pretty straightforward. If I want to have a similar implementation for Webdriver in Selenium, then the syntax would be slightly different, but the selectors remain the same, and the flow of actions is going to be similar as well. And I also provide an example of using an harness for Jasmine and Angular, for instance, where we would use a debug element from the Angular framework, query it by CSS, and then set a native element value. So it's really all about having different implementations of the same interface, in a sense. The harness is your interface of all of the user interactions, all of the different actions that can happen on the component, and then you would have different implementations based on the target of your test. If it's a test that's going to run in the browser with Cypress, you can have a Cypress implementation. If it's a unit test that's going to run with Jest or Jasmine, then you would write the implementation of that interface for that specific use case. But the API remains the same, which is really nice because you don't have to reinvent the wheel for every single type of test that you are writing. So at this point, you're probably wondering, are there any harness libraries available? And the short answer is yes, but not for every framework or language or library. The most advanced library I've found so far is Angular Material, where they have a CDK, a component development kit, that has a component harness API. And they basically implemented all of these features that I talked about. So providing support for different technologies, Protractor for end-to-end, and Jasmine for unit tests, for instance. That's something they have done in the Angular Material CDK harnesses. They provide harnesses for all of the Angular Material components, and they provide support to add your own harnesses for your own components, which is basically creating your own API so that tests can interact with harnesses for your own custom components, just like they would with a regular drop-down or button or tabs from Angular Material. And you're probably wondering, yeah, but I don't use Angular. Can I still use that idea? Can I still use that harness pattern? And yes, you can, of course. As we mentioned earlier, it's all about implementing a pattern where you provide an object with methods that are going to interact with the component itself. And when you think about it, it's actually not that much code of writing such a library. So if you are inspired, why not writing an open source library for your language, library, or framework? So what would it take to write such a component harness library? There's really 3 steps in order to get a component harness up and running. The first thing is to have a target implementation of the harness. So am I going to do that with Cypress or Jest or anything else? So being able to decide what the target is. And you can have multiple target implementations, but start with one. Then we want to have a way to select a component in the DOM. Could be by its type, by its class, or just by a name. Could be a string, basically, or type, depending on the technologies we're working with. And then an API to read information and interact with each component, which is equivalent to the 3 lines of code that we have down here. These are inspired from the Angular material CDK, where they have a testbed harness environment. So this one is for unit test purposes. They also have a Protractor harness environment, which is for end-to-end. But here we say, hey, we're doing a unit test, and we want to have a harness loader for the current fixture, which is the current component that we are testing. Once you have that loader, you're going to query it and say, hey, I want the select drop-down harness. And once you have that harness, you can interact with it and get the options of that drop-down, for instance. So you have access to the API. So it's really all about give me the harness for my target environment, query the DOM and find a specific component that I want to interact with, and then interact with it using the harness API. So that's all I had for component harnesses today. As you can tell, it is an idea that is fairly recent. It is something that really emerged over the past year and a half maybe. I've been using it for a few months now, and I really like the idea. I really think that it makes writing unit tests a lot more productive, and especially the idea that you can reuse that API both for your unit test and your end-to-end test make it really an interesting solution, and something that removes a lot of friction in writing unit tests and multiple different test scenarios, because again, you are going to interact with a very minimalist set of APIs that are easy to read, easy to understand, easy to maintain. So I included the link to these slides in here, and if you have any questions or need anything else, feel free to reach out to me. You can find me on Twitter, on LinkedIn, and I also added the link to my blog right here. So thanks again for your attention, and I hope you learned a few things today. Thanks.
Hey, it's Joe Eames with ng-conf. If you like that video, be sure to click subscribe either here or here, somewhere over here. And if you're looking for something more, here's another video for you to watch here or there or somewhere.